So, good evening, everybody on Facebook who's joining us tonight for another one of our digital online sessions. Tonight, we're going to do a bit of a Q&A with Dr. John Mason, who is the Principal Lecturer at the South Downs Planetarium. Before we go into some questions, though, I really do hope this week you've had a good chance to get and get out there and look at the kind of things we were trying to do with our digital content. So I hope you've managed to count all the stars in Orion. Now I counted about 10 or so in Portsmouth, which isn't very good, but I'm sure some of you had a lot better success. My record is about 33, but I kind of know what I'm looking for. I know where to stand. So if you've got more than 33, you might be younger than me for a start off. My eyes are getting a bit knackered as I get older, but you might live in somewhere that's a lot darker than where I do. Hopefully, you've also seen some of our astrophotography pictures. They were great. Some of the best pictures I've ever seen. The winner of the landscapes with the view down to the valley with the Rampier wind farm is very good. I could talk about that picture for hours, but I'm not going to do that because we want John to talk more often. My favourite thing this week, though, has been watching my Rangers try set up for a star party on a cloudy night. Now, they have shown me up a bit. They know far more about Orion and some of the constellations than I do. So I'm going to have a little word with them when I get back. But really good to see them struggle in the clouds as well. Some good examples, some good lighting. And I'm sure we'll have a question on that a bit later. But one of my highlights that I have working on dark skies, I should say I'm Dark Skies Dan, by the way. I didn't do my introduction. How rude of me. Is that sometimes I get to share the office at the planetarium. John kindly puts me up and I can sit there with a laptop. Now, the thing is, I've been able to get into a few shows every now and again, and I often listen to the questions that come at the end of those planetarium sessions. And I know that all the kids that go inside, all the schools, have loads and loads of questions. And John always comes up and always says, what a great school came up with such a vast diversity of questions. And I've never known him never answer anything. So this over the next hour, let's see if we can test him. Let's see if we can really get him a question that can really tax his mind. So without any of that, I'll just introduce Dr. John Mason. How are you doing, John?
I'm very well, thank you, Dan. And of course, normally during the Dark Skies Festival, we're wrestling with dark skies, trying to turn telescopes for gaps in the clouds, trying to show people things.
We are. I have to say, it's a bit of a strange change of pace. Normally, it's a bit of a rush. We're getting telescopes up, and it's a big run around to get things right. This is a lot more sedate, but this bit where we're live on Facebook is terrifying. I won't lie. This is new for me. But I suggest we start looking at some questions. So, I mean, firstly, you must have watched the Mars landings last night. I mean, you were there, tense as the people were in that control tower. How did you find it?
I thought it was a marvellous coverage of the landing. I think that the commentary that went along with it was really, really good. There was lots of information that was being displayed on the screens that you could see, and you didn't have to take any notice of it if you weren't interested. But if you were interested, you could watch it. And the thing that I think a lot of people didn't appreciate before last night is they were talking about the 7 minutes of terror, the last 7 minutes to get from the top of the atmosphere onto Mars. But of course, there's an 11-minute delay to get the radio signals from Mars to the Earth. You know, it's 127 million miles away, Mars, at the moment. And that 11-minute delay means that you're learning about everything after the fact. And, you know, the craft may have already crashed on the surface 4 minutes earlier before you actually know about it. And that, I think, really came over the delay. And what was also really good was an incredible amount of international cooperation, radio telescopes around the world, picking up signals from not only the lander itself, but also from the two craft that were acting as relays, Mars Reconnaissance Orbiter and MAVEN, and even the Goon Hilly radio receivers down in Cornwall here were part of that global network. So, you know, there was a British involvement in that work that went on last night, but incredible achievement. And when you consider that for the past year, they've been working largely remotely because of the COVID restrictions, it is an amazing achievement.
Yeah, it's really good. It was nice to see some people jump up around and celebrate compared to the last lander on the Comet, which was a bit of a disaster. So this is good to see. And I'd share with you the delay, because when I look up at the sky, the thing that always gets me is your time travel. you're always looking back at things that have happened in the past, all the way back to the 13 billion years ago, the start of the Big Bang. It's out there somewhere. But I have to say, I mean, the delay is nothing but as frustrating as trying to get my kids down for dinner. The delay between me shouting and them coming down to the moment, it's monumentally frustrating. But anyway, let's move on to a question. So the first question, I think, is going to be this one from Judith Hyatt from Uckfield. So we'll start with some questions about Mars first, because that's probably the most important thing that's happened recently. So on NASA TV, when they were showing the testing of the helicopter, they put it in a chamber to simulate the air pressure and gravity conditions on Mars. I can see how they remove some of the air to reduce atmospheric pressure, but how do they adjust the gravity? It seems impossible to me.
Oh, what a great question that is. Now, Mars has only about 40% of the gravity that we do on Earth. So you put the helicopter in a chamber, you can evacuate the chamber to 1% of the atmospheric pressure. So far, so good. That's why you have to have these rotors spinning at about 2,600 RPM to create the lift. But the copter, as Judith correctly says, is trying to lift off in Earth gravity. So what they arranged was a really ingenious gravity compensation scheme. They used a motorized lanyard that they tethered from the top of the chamber to the top of the helicopter. And the motorized lanyard provided a force equivalent to 2/3 of the gravitational acceleration of the Earth. So in other words, the Earth's gravity is pulling down by its normal amount, but this motorized lanyard is pulling up by about 60% or so of Earth's gravity, which means that the helicopter is feeling the right force acting due to the Earth's gravity.
That's a great,
really?
It's a great answer. You've taken me right back to first year physics with the Einstein's apple in the lift.
Yeah.
And knowing about how we kind of, if you're around a big gravitational mass, is this, if you're in a lift and you couldn't see outside and you threw an apple up in the air and it came back down and landed, what would happen if the lift was in free fall? Because you'd lift the apple up, the apple would just stay in the middle of the lift. So you've just, you've just taken me right back to some very, very difficult lectures. I remember.
Realise, of course, that the mass of the lander doesn't change. All that is changing is its weight, and your weight depends on where you are and the local acceleration due to gravity where you are. So if you are a 60 kilograms on the Earth, you will weigh only 10 kilograms on the Moon. So 1/6 as much. A 60 kilogram person will weigh about 25 kilograms on Mars.
Yeah, and that's the important thing, isn't it? Well, we have such big rockets to send these things into space. It's because we need the acceleration to escape the velocity needed to get into orbit. So that's why we need that warmth.
When you launch something from the Moon, or when we eventually launch something from Mars, we won't need as powerful a rockets to do that because we're working against a weaker gravitational force.
Absolutely. So we'll kind of on that and getting into orbit and things going round and round in space. We've got another question here from Liz Green, and she says, "What will happen to the heat shield and the crane mechanism that were released into space? Are they going to orbit anything, or are they just going to drift off?"
Neither of them are in orbit. They both were released during the atmospheric descent. So the heat shield was jettisoned fairly early on in the 7 minutes EDL. And that eventually would have fallen onto the surface of Mars a long, long way from the landing site. The sky crane is an interesting one because that last 20 meters, 70 feet or so, is where the sky crane is lowering the rover down on the 3 cables. And then as soon as the rover touches the surface, the sky crane feels the sudden change in the tension on the cables. The cables are cut, and the sky crane then flies away. Now, interestingly, the sky crane would have gone towards the north. It was programmed that however it came down, that sky crane would head off towards the north and would come down and basically crash on the surface of Mars some way away from where the rover was. So both of those things, the heat shield and the sky crane, are both on the surface of Mars now.
So to be good stewards of this planet, we should really take care of Mars as well. So presumably we'll have to go up there and pick up our rubbish. So this is a question really from Hannah Millard. She says, do you have an opinion on Elon Musk and whether he has the same or different opinion on the possibility of humans living on Mars? So maybe they can go up there and pick up the heat shield.
Well, I definitely think that humans will be living on Mars. I can't say when. I think it's probably going to take longer than some people think. But Elon Musk has a vision. He also has the money to back up that vision. And he has been incredibly successful in developing rockets and spacecraft to fulfill his dream. He's still some way from sending people around the moon or sending a craft to the moon, and even further away from sending craft or people to Mars. But I'm quite sure it will happen. What we can't say is when. Now, NASA obviously has their Artemis program, which is to basically send astronauts back to the moon, including the first woman to land on the moon, and also to then move on to sending rockets round Mars and to Mars. But the thing is, the moon is always going around the Earth, and to get to the moon and back is relatively easy. It takes about 3 days to get there and 3 days to come back. So if you leave early on Monday morning, you get to the moon late on Wednesday, turn around to come back, and you're back on Saturday, time to do the weekend shopping. So it's pretty easy. But a trip to Mars is much longer because Mars is much further away. And also because of the relative orbits of Earth and Mars, you can only really launch to Mars every 25 months when Mars and the Earth are positioned correctly. So a trip to Mars is going to take you, say, 8 or 9 months to get there. You're then going to have to wait a bit on the surface of Mars before you can make the return journey, and then 8 or 9 months to come back. So you're going to be away for, not best part of 2 years on a trip to Mars. This is a very difficult and different undertaking to a quick round trip to the moon. So yes, I do believe it will happen, but I don't think it's going to happen soon. Whether it's Elon Musk who does it, or whether it's NASA or the Chinese or whoever does it, it's going to be a long and tricky path to send humans to Mars.
The interesting thing is, I mean, my interest in science came from science fiction. So I'll be interested to know what you think a base on Mars would look like. Would it be something like Total Recall, The Martian with Matt Damon, War of the Worlds, or Red Dwarf? I prefer Red Dwarf. If we had any kind of reality, that's what I'd go for.
I think it's going to be more like the base in The Martian. The Martian is actually a very good film. Apart from the nonsense at the very beginning and the nonsense at the very end, the middle bit is pretty good in terms of scientific accuracy and realism. And I think that in many ways, living on Mars is going to be a bit like that. Growing plants in human poo and all that sort of thing. That's probably really going to go on. And one of the interesting things about this latest mission is that on the Perseverance Rover, there's an experiment called MOXIE, which is going to look at converting the carbon dioxide in Mars's atmosphere into oxygen. Now, if that works, that could be really important because we can make oxygen for people to breathe. We can make oxygen that we can use for fuel. And the more resources that we can use on Mars without having to take them to Mars, the better it will be.
Yeah, I mean, I remember the applicants for the Mars mission, aren't they? It's a one-way ticket at the moment, isn't it? I mean, you're not putting an application in?
I'm not a believer that one-way tickets should ever be undertaken. I believe that we should be sending people to Mars with the expectation we will be bringing them home again. And the idea of having some grotesque game show which people would take part in to go to Mars on a one-way ticket, I find as a scientist fairly abhorrent, I have to say.
Yeah, it's a little odd, isn't it? I think you have to be a special kind of person to want to do that. But very much an explorer. But yeah, just talking about Elon Musk then. I mean, one of the problems we get in the Downs now is the satellites from his Skylink wireless, I think is what it is. And that's real. So I suppose my question is, you know, the technology that Elon Musk could bring to manned missions and exploring the solar system, how would you trade that off against things like the satellites that enable him to do it? Because you're going to lose some part of the night sky with that. So what would you prefer? I mean, is there a middle ground?
I must admit, I am not a fan of Starlink because it's the thin end of a very big wedge. Other companies are planning to launch tens of thousands of satellites into Earth orbit. One thing I will say is that Elon Musk's team are going quite a long way to engage with astronomers to try and make their satellites less visible. And that is good news for everybody. But whether all the companies who are going to launch these massive constellations of satellites are going to be taking notice of what astronomers think, I don't know. And I would hate the fact that you would go out on a summer's evening and gaze at the night sky, and instead of all the stars, you'd also see hundreds of these star-like points moving across the sky. I think that, you know, the night sky should be a pristine, unspoiled environment as much as we can. Just like, you know, we all believe that the South Downs National Park should be a pristine, unspoiled environment where we can all enjoy it both during day and during the night. And I think all those things are equally important. So I am very concerned about satellite mega constellations. I will give great credit to Elon Musk's SpaceX team that they are engaging with astronomers and they are trying to make those satellites less visible, but the sheer numbers of them poses additional problems. In particular, you mentioned earlier about us leaving junk on Mars. Well, space junk. When you've got so many thousands upon thousands of satellites in Earth orbit, collisions will eventually occur, and they will create a lot of small debris, much of which may come down eventually. But I do think that this whole area has got to be looked at more carefully. Just because you have the ability and the power to launch 240 satellites in one go on a huge rocket doesn't necessarily mean you should be doing it without thinking of the consequences long term.
Yeah, I mean, that's interesting, John, because what you've got there is one of the environmental philosophy points that I remember learning, the tragedy of the commons. You know, if everybody uses it, no one takes care of it because they expect someone else to kind of clean up the dirty work or no one to do it. So are you kind of hinting that you'd like to see space privatized? No,
I definitely don't want to see space privatized. In fact, the opposite. I would like there to be much more accountability with organizations like the International Astronomical Union, the United Nations Council for the Peaceful Uses of Outer Space, lots of organizations like that taking charge of what can be done and making sure that it's discussed and debated. A bit like, you know, if you go back to the 1980s, people were sticking up incredibly bright, inefficient lighting everywhere. And that basically doesn't happen much now because we've taken the time and effort to talk about it. It's taken 3 decades or more. You know, people like you and Bob Misen have been doing this all this time, but it's made the whole thing better. And we've got to have now a similar dialogue about satellite mega constellations and the peaceful uses of space.
Well, I think I'll be first to volunteer to go into space to turn some of the satellite lights down. I mean, I can just do that maneuver on the side of a satellite. I'm happy to do that.
It's like a computer game, zapping them with a laser. Yeah, but that, you see, I'm against weaponry in space as well, to be honest.
Yeah, we should say nobody put their lasers into the sky because you're not allowed to do that. So don't listen to John on that one.
Absolutely not.
Absolutely not. Right. So let's move on to another. Let's move on to a question from Paul Scott again on the on Mars. Does Perseverance have the ability to dust itself off after an atmospheric storm?
Oh, that's a great question, Paul. Now let's think about previous rovers. We'll think particularly about Spirit and Opportunity. Now, Spirit and Opportunity, which were the two previous Mars exploration rovers before Curiosity and Perseverance, they were solar powered. So they required solar energy during day to recharge the batteries of the rover to keep it going. Now, when we had big dust storms on Mars and the dust coated the solar panels, obviously the efficiency of the charging dropped and we had to wait. Now, fortunately, what sometimes happens is that when the dust storms clear away, there are winds that blow on Mars, particularly if you're on a flat plain area or maybe high ground, and the wind blows the dust off, which is very fine and, of course, extremely dry. It's not damp, extremely dry. So the winds tend to blow the dust away. And we got away with it until the last major dust storm back in 2018, when Opportunity, which was working away still then, was caught up in this very major dust storm, and eventually the batteries couldn't be recharged and it died. Now, that is not going to happen with Curiosity and Perseverance because they are not solar powered. If they get caught up in a dust storm, they will still keep going because they are powered by thermoelectric generators, and they can last for up to 10 years, providing continuous electrical power. So yes, the dust may deposit. It will slowly eventually get blown away off the rover as it moves around. So they don't have a mechanism, if you like, for sweeping the dust off, but it's not going to be the same problem as it was with the two previous rovers, which were solar powered.
Yeah, the technological advances are great, aren't they? Think of everything. But kind of on that, we've just had a question come in live. Now, there is a lot of dust up there. Can't sweep it up. We just talked about total recall. I remember at the end how it was all terraformed. And the question is, do you think it will ever be possible to terraform Mars into an environment similar to Earth's, or will that always be science fiction?
It will always be science fiction, and that's because we can't change Mars's gravity. Mars at one time had an extensive atmosphere and a fairly strong magnetic field. When the interior of Mars cooled and the magnetic field got very, very weak, the solar wind, this stream of particles coming from the sun, was able to strip away a lot of Mars's atmosphere, leaving us the very, very thin atmosphere, only about 1% of Earth's atmospheric density that we have today. If we were going to try and create an atmosphere on Mars, it would always leak away into space because we can't stop that happening. So if we're going to live on Mars, as I'm sure we will, it's going to be life in a bubble. Now, that might be some form of large domed enclosure, which we fill with air at the right pressure. And when you go in and out through an airlock, you have to wear a spacesuit when you're outside. I don't think, as in Total Recall, that if you go outside without any form of spacesuit, that you'd be able to survive in that 1% of pressure for anything like the length of time they do in Total Recall. You would die fairly quickly in a very nasty death as well. But it may be that we would live underground on Mars. It may be there are cavern systems deep underground on Mars, which might be completely airtight, and you just need an airlock or something at the entrance, and you could live in a great underground cavern system. We haven't yet explored those underground cavern systems on Mars, but they do exist in the flanks of the extinct volcanoes. So I do think that once the NASA potholing team gets going on Mars and starts exploring these caverns, we may find there are other opportunities for living on Mars in the future. So I do think we'll live on Mars, but I don't think we'll terraform it and making it like the Earth. It's always going to be a very different environment and a different experience.
Yeah, I remember years ago, decades ago, there was that experiment that NASA did with the biomes. Do you remember that? And they got 5 or 6 people to live in a biome, and I think it went wrong because they couldn't really make it.
It was this large domed enclosure. I visited it in Arizona, and it's an interesting place. You can still visit it by appointment now. It was a failure because they didn't really have the biosphere balanced so that they had enough oxygen being produced, enough CO2 being removed from the actual biosphere to enable them to continue as normal. And they were having to, you know, top up the oxygen and things. There were also, the people inside got a bit fed up with their isolation after a while, and this was another problem. But these biosphere experiments are important. And of course, even today, part of normal astronaut training is to go into enclosed environments. So, for example, there is the environment off Florida that Tim Peake stayed in for some time on the bottom of the ocean, getting used to being in a small confined volume, having to put obviously a diving suit on to go outside, but with little communication with the outside world except, you know, radio communication. So these biosphere experiments are important. And as I say, Biosphere 2, which is in Arizona, was a very good experiment at the time, but it didn't actually work. There were a number of problems they weren't able to address.
Yeah, well, I think that's one benefit of lockdown is now we have an entire generation of people who can live in confined spaces for long periods of time. So we've got no shortage of people now. So that's all right.
Do they like it?
That's true. Yeah, as long as we've got Netflix. I mean, that's probably what they missed in Biosphere too. They didn't have Netflix. That's what it was. They couldn't binge watch anything.
Could be right.
Could be right. So let's just end with this little bit on Mars then. It's people would like to know how they can keep up with the progress of Perseverance and, you know, if it can find life. I mean, I'm a kind of believer that there's life out there. The laws of physics are everywhere. We are a manifestation of those laws. So why can't there be life elsewhere? I mean, so how can people keep a track on Perseverance and things like that?
The wonderful thing about the Perseverance rover is it's operated and managed by the Jet Propulsion Laboratory in Pasadena, California. They have second to none resources for teachers, general public, media, a whole range of videos, stills, explanatory notes, things you can print off. So you just need to put NASA Mars Perseverance Rover in Google and it will take you to that particular site. You can do it now and you'll see exactly what's going on. All the latest pictures will be there. Now, up until when we started this Facebook Live, there were only 3 pictures that had been released by the Pasadena team. I can tell you that they have been streaming images from the rover to 2 spacecraft flying overhead and back to Earth. And that will include a video sequence of the landing. The spacecraft was taking pictures as it was coming down all the way through to the landing site. It was also recording sound, and we are going to get that video fairly soon, together with new pictures of the landing site. So that's going to be fairly soon, within the next day or 2, and keep an eye out for that. But it is very easy to keep up with it. But I would say this, make sure that you go to the official NASA JPL site, because there are other sites that take information from the NASA site and maybe alter it or change it, and it may not be quite as accurate. So make sure you go straight to the horse's mouth, as it were, and go to the NASA JPL Mars Perseverance 2020 rover site.
Brilliant, thanks, John. I bet you didn't even have to look that URL up. I mean, that's you remember it. That's amazing.
Yeah, well, obviously all the stuff last night was on it. There's amazing film that we had from last night from the mission control in the JPL. It's an amazing place.
Yeah, just like the planetarium. So this leads me on to my next question. And is I mean, I've been there. I've seen what you've done and how you got the place started. But how did you get started in astronomy?
31st of July, 1961. That was the date that I was switched on to astronomy. It was in the start of the school holidays, And my parents and I had been up to visit a very elderly aunt somewhere on the outskirts of London. And my parents always got lost coming from that particular aunt. And of course we got lost and we got home very late. It was probably about 11:30, something like that, that evening. And as we were getting out the car, and I lived in Littlehampton at the time, and Littlehampton was then a pretty dark place. You could see the Milky Way from the back garden in our town, in the town. And as I got out the car, and I looked up, and a really bright meteor shooting star streaked across the sky, just as I looked up. And I was absolutely fascinated by this. And I said to my mother, what is it? What made it? Why is it there? And she got a little book out of Littlehampton Library, and I find out more about it. And eventually I read all the astronomy books in Littlehampton Library. There were 6 of them at that time. And for my 8th birthday, the following April, I received a book from my sister, which was the first astronomy book I ever had. And it was the Observer's Book of Astronomy, written by Patrick Moore, 1962 edition, and it cost £0.50. So 12.5 pence in new money. And I read that book from cover to cover a dozen times. And I still look at it now, and it was an amazing little book. And I was very lucky when I was a little bit older that I met Patrick, and he was my friend and mentor for 45 years. And without him, I wouldn't be sitting here talking to you now. He inspired me and encouraged me and helped me more than I can remember. But also my parents realized that this was going to be a big thing for me. So I would often be sitting out in the garden in a deck chair with a star map and a red torch, learning my way around the sky, but they'd gone to bed. And I bought a pair of binoculars with the money from my paper round. They were second-hand, ex-War Department binoculars. I've still got them, beautiful binoculars, very heavy, but brilliant optics. And I started learning my way around the binocular sky. And then when I was a teenager, my father and some friends of his helped build a telescope. And I had the telescope in the front garden, and I started to use that. And then when people at my school, Chichester High School here, realised they would come round of a weekend and we would look through the telescope and we'd have a whole group of us. So that's how I got going, really.
Yeah, I mean, I remember mine. It was a book that my parents gave me. It was a combined Skywatcher's Handbook. I think you've got it in your library actually, but yeah, it was a combination. It was a blue one. It was a combination between the weather, which I love reading about the weather and the climate and things like this, but also all the astronomy stuff. And I remember looking at a date for the eclipse, seeing it was in Cornwall in 1999, and I kept that book. I kept that book until the day I was there at Newquay watching the eclipse, thinking if it wasn't for that book, I wouldn't be here, at the right time seeing it. So a good book is very underrated, I think.
There were 2 things in the Observer's Book of Astronomy, 1962. One was the total eclipse of 11th of August, 1999. And I said to myself, I'm going to be in Cornwall, whatever the weather's going to be like, I'm going to be in Cornwall. I'm very fortunate, and I've seen many total eclipses now. And the other thing was the Leonid meteor storm of the 17th of November, 18th of November, 1999. And I vowed I was going to see that. And I went to the Sinai Desert in Egypt, and it was one of the most incredible spectacles, with the sky filled with shooting stars, one a second everywhere you looked. It was just amazing.
See, it's interesting. You're doing the same thing that everybody does. When I do my talk on dark skies, and I say, there's nothing like the power of a dark sky. You can always remember when you saw it for the first time. You've got the same smile on your face that everybody else has. So I'm going to ask you, this is my question, right? So on my bucket list, I think you've been there, but I'd really want to go to I think it's in South America, but there's a salt lake that at the right time of the year it rains. And if you stand there, there's nothing else around it, you get a complete 360 view of the sky because it's reflective. So that's my bucket list. Where would you recommend, if anybody could go on a one bucket list, where's the best place you've seen in the Milky Way?
Now this is a very interesting question, because people will think that it's from a really, really high mountain site. Now, I've been to the top of the Andes, over 14,500 feet up in the Chilean Altiplano, and that is not the best view of the Milky Way I've had. Because there's less oxygen in the atmosphere at that altitude, your eyes do not work as efficiently. So the naked eye view of the sky is not as good as a really dark place at sea level. So the answer to your question is the island of Hao, H-A-O, which is a tiny atoll in the middle of the Pacific Ocean in French Micronesia. And that is the best view of the Milky Way I've ever had. Nearest street light, 1,000 miles away. And it was so astonishingly dark, and the Milky Way so bright that objects which you can only see in binoculars normally stood out with the naked eye. Eagle Nebula, Lagoon Nebula, utterly astonishing. And that's at sea level where your eyes are working at maximum efficiency. But of course, it's very important to get dark adapted. It's no good going out of a brightly lit room, or you've been looking at the bright screen on your phone and you suddenly look up. You're not going to be dark adapted. You need to be standing outside in pitch dark 15 minutes or so and then look up. I remember back in 1996, March, there was a comet called Comet Hyakutake, and it passed close to the Earth at the end of March that year. And a friend of mine and I, we drove out to Upwaltham, near Upwaltham Barn, where there's a natural bowl in the Downs. And we got there, we turned off the lights and we sat in the car for 15 minutes. And we got out and we looked up, and it was the most astonishing sight. The tail of that comet stretched halfway across the sky. And I've never seen the like of it since. I've seen some incredible comets, including, of course, Neowise. And you've got some amazing pictures of Neowise in your photographic competition. Beautiful pictures. I've been really enjoying looking at them. But that showed the value of dark skies and of dark adaptation. Seeing that comet's tail stretching halfway across the sky, I've never seen the like of it since. I'll probably never see the like of it again.
Yeah, it's funny because we get asked about where can we go to see stargazing in the South Downs, and usually we just kind of direct people to our dark sky discovery sites, which are great places to go. But the map we developed that showed all the different areas which you could go to, that's kind of like a challenge to people, from me, to go out and find these little nooks and little crannies. Because you're right, because there are hidden little all over the Downs that, you know, if you find it, it's amazing.
Barnes again recently and was really disappointed.
Oh.
Because the lights of Petworth and Midhurst, although they're quite a way away, they are significant to what it was back in 1996. So I have to say, one of the darkest, if you go up towards Gumber Farm, up that way on my part of the Downs, that's a really dark place. I mean, well, I'm still trying to find places. And as you know, we're trying to refine the dark sky map and refine the measurements and find dark places. There are probably really dark places that we can find, even better than the ones we know so far. We've just got to hunt them out.
Oh yeah, exactly. I mean, my rule of thumb is just to get away from the big towns and the cities and get the north side of the Downs.
Yeah.
Because the Downs are like a bit of a sunglass wood.
They are.
Yeah, and they'll cut out some of that light. What I do is time to time try to take a lightweight telescope with me. I see you've got one there behind you.
Yeah.
I mean, that's a really good beginner scope. I mean, that's one question that does get asked a lot, is how can I start? What's a good thing to buy? So maybe while that's there, you could just go through that for me.
This is a telescope, which is a 4-inch, 100mm Skywatcher refractor. It's on a fairly robust mount, and you can pick up the whole thing for about £400. Now, people often say, is it worth buying a cheap telescope? And I would say no. There is no such thing as a good, cheap telescope. They're either good or they're cheap. But telescopes like that Skywatcher, you can pick up on eBay for 150 quid. And because they're fairly robust and the optics are in a tube, solidly mounted, there's not a lot that can go wrong with them. And those telescopes will give great views of the moon and planets. They won't be quite as good on star clusters, nebulae, that sort of thing. For that, you need a reflecting telescope. I've got one over here. It's pretty heavy. I can't move it. That's an 8-inch, 20 centimetre reflector. But you can buy 6-inch, 15 centimetre Skywatcher reflectors. Again, they are probably only about £350 with a good mount and a couple of really nice eyepieces. So if you're prepared to spend £300–400, get yourself a 6-inch Skywatcher reflector or a Skywatcher refractor like that, that's a good starter scope. But the telescopes that you buy in some camera shops that you'll often see advertised in the Sunday newspapers, I really wouldn't touch them with several barge poles.
I mean, that's great advice. I mean, you're right. You get some very, very cheap, yeah, binoculars. Yeah, absolutely.
These are very underrated. I really love binoculars for astronomy. These were bought from Lidl. Now, occasionally on a Thursday, Lidl will do a loss leader on binoculars. And I think I bought these for $10.99. They're worth 3 times that. The price did go up over the years. I think it was $14.99 last time they did it. But keep an eye on Lidl. They have these lovely Bresser 10x50 binoculars, which are really good for astronomy. And hey, they're good for bird watching. They're good for watching the wildlife in the park. They're good for just scenic gazing. They are really good buy, and you can't beat them in terms of value. So Bresser binoculars, I don't know when Lidl are going to have them next in again. They might not, they might do. But Thursday's the day to go because they get snapped up really quickly. My volunteers generally buy them up and then we bring them to the planetarium here so that we can lend them out to people. So binoculars, you know, I do not think that they're not a good thing for astronomy. They are. The first optical instrument I bought was those binoculars with the money from my paper round, remember? And I used them for years and years and years.
Yeah, they're a great way to start. So now we know if you'll be in the queue at Lidl, you'll be first. So we'll know when the binocular run is. I mean, one of my lasting memories of doing the dark sky stuff is using one of those larger reflecting telescopes that we've got. And I remember seeing a supernova and technically, if you include the Milky Way, 3 galaxies in the eyepiece at the same time. I think it was Cigar Galaxy was in the. It was near
M82, M81, M82. Yeah,
that's right. Yeah, I remember. I could still remember seeing the supernova in a galaxy that was, you know, bonkers distance away. So, I mean, for me, the fascination with dark skies is always a bit of the unknown. That's why I kind of got interested. It was understanding some strange things out there. So, what do you think is the strangest thing in the universe?
There are quite a few strange things. But I think the strangest thing in the universe at the moment is vacuum energy. Now, we've known for a long time that the universe is expanding. It's been expanding ever since the Big Bang nearly 14 billion years ago. But in the late 1990s, we discovered that the rate of expansion appears to be accelerating. Now, we'd assumed up to that point that the rate of expansion would go on, but getting steadily less and less and less and less into the future, and eventually everything would carry on expanding, but at an ever slower rate. Where this discovery was remarkable is it showed that the rate of expansion was speeding up. We live in an accelerating universe, and that meant we had to propose some form of mysterious force acting in opposition to gravity. The universe is caught in a tug of war. Gravity is trying to pull everything in, but its influence is getting weaker as everything moves further and further away. But the vacuum energy is pushing the opposite way. What on earth is it? What is the mechanism by which vacuum energy works? Nobody knows. To me, that is one of the strangest things in the universe.
Yeah, I would agree with you. It's that, yeah, gravity is such an odd force compared to the other ones that I mean, I like a bit of string theory, and, you know, the idea that gravity leaks from a different dimension is it's tantalizing. But let's bring it back down to earth a bit, and not looking at strange things. Saturn is a great thing to look at through an eyepiece. We've got a question from Lawrence, age 6, is asking, what is the distance in kilometers the Saturn ring. So I think he means the circumference. So if he stood at one end and he walked all the way around, how far would he have to go? I have to get my calculator out for this. What's 2 pi r, isn't it? That's the circumference.
Yeah,
I can't remember.
basically, it depends on whether you consider the bright visible rings that you see through a small telescope, or you include the darker rings that basically are beyond those. But the interesting thing is, the moon, we said earlier, about 250,000 miles away. If you took Saturn and its rings, they would fit between the Earth and the moon. So in other words, the diameter of Saturn's rings from one side to the other is about the distance between the Earth and the moon.
There you go, Lawrence. I hope that that answered your question. The thing I find interesting about Saturn's rings is the gravitational resonance. Yeah. I think it is. Isn't it? That's really because it obeys the golden ratio 1.614, and that's a number that repeats itself elegantly all throughout nature, from your fingertips to the Saturn to the whorls of a sunflower. And it's great because it just shows a level of complexity, and I don't want to say the word design, but it's the only word I can think of. It just permeates everything. And this efficient number, 1.614, the golden ratio, you can find it in your fingers, you can find it in the stars. I think that kind of connection is that
yeah,
bends my mind, that kind of thing.
I mean, Saturn, of course, at the moment is too close to the sun to be seen. This coming summer, we're going to have Jupiter and Saturn fairly close together in the southern sky. Now, of course, we know that just before Christmas, on the 21st of December, Jupiter and Saturn appeared so close in the sky that you could see them in the same telescope field. They've now moved apart. Jupiter has overtaken Saturn on the sky, and it's now some way to the east of Saturn as you look at it in the sky. But this coming summer, Jupiter and Saturn will both be on view in the southern sky, and it's well worth taking a look. And Saturn is one of the finest objects you can look at through a telescope. Seeing the rings for the first time is incredible. I can still remember that day when I went round to Patrick Moore's house and he showed me Saturn through his big old 12.5-inch telescope with the wooden mount. And it was a life-changing moment. I have never seen anything so amazing. He had to lift me up to the eyepiece because I wasn't tall enough to look through it. And Saturn was just amazing. So it's one of those things that everybody should see. A picture in a book, yes, the real thing. And you know, the amazing thing, I'm sure you've had this, Dan, as well. People often look through the telescope, they see Saturn, and they say, wow, that's beautiful. It looks just like the pictures in the books. As if you expect something different, but it does. It really does look like the pictures in the books. It is a wonderful thing to see.
Yeah, no, the rings of Saturn is a highlight. And for me, it's weird. When I see Saturn, it reminds me, I don't know why, but it reminds me of being a kid in the 70s for some reason. Because I do know why. It's my dad used to read a lot of science fiction. It was, those long, turgid books about Dune and, Arthur C. Clarke and Asimov that I tried as a 10-year-old and couldn't get on with. But I remember the front covers of all of them.
Oh, yeah.
With rings. So whenever I see Saturn, I think I'm in a science fiction film. It's brilliant.
Yeah, I mean, it's great you mentioned those old science fiction books. I know that a lot of people don't like Frank Herbert's Dune series. I must admit, I didn't get on with the second and third books, but the first book I read, and although again it's been heavily panned, I do like the original Dune movie. To me, it's very atmospheric, and I like the whole feel of the film. They are remaking it, I believe. They are remaking Dune now, so I don't know how that will turn out. But science fiction has always had a great interest for me. I read Asimov and Arthur C. Clarke, and went to see 2001 when it first came out in the 70s, and couldn't understand a lot of it, but still thought it was amazing. And I can look at it again now and still not understand all of it, but it is an amazing piece of cinematography even now.
Yeah, I think I escaped all that kind of stuff. I remember Hitchhikers, and of course Star Trek.
Yeah.
But Yeah, but I think a lot of the questions that are coming in now from Austin, age 10, probably won't know what the hell we're talking about. So let's answer his question. Let's go back onto a bit of Mars. So we've got a question from Austin. He wants to know how the Perseverance MOXIE experiment to produce oxygen on Mars will work.
Basically, they're going to take carbon dioxide at very low pressure from the atmosphere, and they're going to split the carbon atom from it and basically see if that will work. And this method can be, you can do it in a terrestrial laboratory, and you can split the carbon from the oxygen. And basically, if we can do that on Mars, and we can do it reliably, because Mars's atmosphere is, nearly all carbon dioxide, albeit at very low pressure. If we can find this way of splitting the CO2 molecule, getting the carbon away and leaving the oxygen, then that would be a really important thing to do. So it's one of the what we call technology tests that this rover has. This particular rover has tested a lot of new technologies. While it was coming down yesterday, there were new technologies being used to get that rover down on the surface. It was in control of its own destiny, its own descent. Very sophisticated programs linked to the cameras were moving the rover to enable it to take pictures of the ground, identify the pictures on the ground with an internal map stored to know exactly which direction it had to go to bring it down next to that ancient river delta in Jezero crater. And it's actually remarkable that after a 293 million mile journey, they bring it down within a mile and a half of the edge of where that river delta is. So there are lots of technology tests, all the things that went on during the landing, the terrain relative navigation that helped bring it down at the end and brought it down in this beautifully flat area with very few boulders. Remember, there were large boulders elsewhere. There were cliffs that it could have got near. It managed to avoid all of those. And we've got the Ingenuity helicopter. That's another technology test. We've got the new hazard avoidance systems. We've got the new way in which the rover will plan its own route across the surface of Mars. So the MOXIE experiment is just one of many, many technology tests that this rover carries that will stand us in really good stead for future Mars exploration. So, when you're older and you're at university and thinking of studying planetary science maybe, these things will be a reality, and every Martian rover and exploration system will have them.
Yeah, I mean, that leads on to another question that's coming from Melanie. So how can we be sure there is really water in the area where the probe landed?
The thing about water on Mars, of course, is what water there is either stored in the Martian polar caps, or it might be in very, very thin white clouds of ice crystals overhead, or it will be as permafrost underground. This particular rover's mission is not primarily to look for water, but to look for deposits left when the lake that was in Jezero crater dried out. Now, we think that 3.5 billion years ago, Mars was very different to the Mars today. Today, it's bone dry, bitterly cold, very thin atmosphere. We believe that 3.5 billion years ago, when Mars still had this magnetic field, it held on to a much bigger atmosphere, denser atmosphere. The temperature on Mars was a lot warmer, atmospheric density was greater, and liquid water could then exist on the surface. There were rivers, there were lakes, small seas. And we know that a river came in through a breach in the crater wall into Jezero crater, and that river drained a huge area of Mars and brought down dust and silt and material called clays. And it dropped all that material as the river fanned out into this crater. Jezero crater filled with water. to a depth of maybe 1,500 feet, because that's how high the crater walls are. And we know the water overflowed into an outflow channel on the far side. So it was a deep, large lake, nearly, 28 miles across. And when it dried out, as it eventually did, because the Martian atmosphere leaked away into space, temperatures dropped, as the water dissipated, material in the water, particularly carbonates, maybe the remains of microorganisms brought down by the river, were deposited in that river delta. So we're not so much looking for water, we're looking for what the water left behind when the lake dried out. And it's those samples that the Perseverance rover will be collecting, drilling down, taking these core samples, storing them away in little tubes and leaving them on the surface for a future lander to come and pick up and bring them back to Earth. And what an incredible achievement that will be.
Yeah, absolutely. And I always think one of the best things you could do is kind of get the comparison between the river systems and those kind of features on Earth. So there's Chris Hadfield's book, the one he took a camera up, didn't he? He took loads of pictures of planet Earth. And some of them are so good. You can see the similarities with Mars, and you look at it and you think, well, that's definitely a river on Mars. That was a river, and you can see that. So that again, it's looking at a good, decent book that kind of gives you that inspiration.
One of the things that I remember many years ago, I was on a plane flying to Canada, and we went across Greenland, and we took a slightly more northerly route than normal. And, in those days, they let you walk around on planes, and I would get bored and I'd be peering out through the window in the emergency exit door at the back, watch it as we flew across Greenland. Now, there are bitterly cold, dry valleys in the Martian northern polar ice cap, which are very similar to the bitterly cold, dry valleys that you find in Greenland. And in my mind, as I looked out of that aeroplane window flying across Greenland, I was flying across the North Polar Cap of Mars. And I remember turning to the flight attendant, the lady there, who was wondering what I was doing. I said, "Oh, it's just like flying across the North Polar ice cap on Mars." And she looked at me as though I was completely bonkers and walked away. But to me, that's what it was. It was as though I'd been there.
Yeah, I've always read about Mars and fancied climbing up Olympus Mons, but I think it's so big, you wouldn't really notice you're on a mountain. So a question's come in to say, how big is Jezero Crater?
Jezero Crater, as I say, is about 28 miles in diameter. And we know that in places, the crater walls are between 1,400 and 1,600 feet high. It's obviously much wider, and the walls are perhaps not as high as many people think. But for that to fill with water, that's quite a volume of water that was there once when we had this deep lake in Jezero Crater.
Yeah, it's a lot of water. So we're nearly out of time, John. So I'm just going to ask you what you think about the future missions for NASA. And you mentioned the Artemis 2024, but I mean, what's next? Has there got anything up there? NASA laboratories?
Let's think about. We've already had samples brought back by the Japanese probe of the asteroid Ryugu. We've got OSIRIS-REx bringing back samples of Bennu. So we're going to have samples of asteroids. Perseverance is going to collect these samples on Mars. It's got this really sophisticated sample collection system. And then in a joint European-American mission between ESA and NASA, there is going to be this mission, 2026, probably not, 2028 maybe, to send a spacecraft to Mars, to land in Jezero Crater, to send a European lander to go and collect these samples, to bring them back, and then for an ascent stage to lift those samples off from Mars and bring them back to the Earth for analysis. Because only with the really sophisticated analysis equipment that we have in terrestrial laboratories will we be able to really examine those samples for the detail we need to say, are there signs of ancient microbial life in those deposits in Jezero crater? And if the answer is yes, that is an incredibly important answer. If the answer's no, it's an incredibly important answer. If the answer's yes, it means that life began on 2 planets in our solar system at about the same time, 3.5 billion years ago, on Mars and on Earth, but it died out on Mars because the planet changed beyond all recognition. Earth was a more stable environment. If the answer's no, and there's no sign of any microbial life, past microbial life at all on Mars, it may mean that life is very rare. And that would be an equally important answer. But one of my great wishes is that I live long enough to see a space mission to Jupiter's moon, Europa. Europa is one of the 4 big moons, Io, Europa, Ganymede, Callisto. It's the 2nd big moon out. And Europa is an icy moon, but underneath that ice layer, there is a deep, warm, salty ocean that may contain more water than in all of Earth's oceans. And some people believe that there could be some form of strange marine life, microorganisms living in that ocean under the ice cap of Europa. What a mouth-watering prospect to go there, to examine it, to drill through the ice, to launch a mini submarine, a hydrobot to explore that under ice ocean. I'm not sure whether I'll live long enough. I hope I do.
Yeah, same here. And of course, I'll be looking for the most important object, which is the monolith.
Yes. They tend to turn up in deserts in Utah.
They do, yeah, very mirrored ones as well. Not quite the same, are they? Not quite the same. Well, listen, John, we've had an hour now, so I hope our audience has come to realise just what a great encyclopedic knowledge you have of current astronomical things, and just what a kind of resource you are down there in the South Downs Planetarium. So, I mean, what's up for the planetarium the next couple of months? I mean, you're in lockdown, but you normally have a good program of events, and you're always up to new stuff. So,
as the government allows us to open, we will be opening, but we will be following exactly the same social distancing, safety procedures that we followed previously when we were open in September, October, and for that 1 week in December. So, you know, we'll still be having social distancing. It'll be small audiences. We shall still be exhibiting great care, but we will be doing shows for the public. And eventually, we hope to be doing shows for schools and colleges and university students, which is what we would do normally. We normally have about 17,000 visitors here a year, of which 10,000 are children of school age. And I look at the lockdown as having deprived 10,000 children of the planetarium experience. And that, to me, is a tragedy. So we need to try and make that up somehow.
Absolutely, and I started saying, you know, at the very start of this, when I was upstairs and you used to come up after the sessions, you could hear all the kids just give a round of applause, all the way from 4 till 15. Everybody loved it. I remember. I mean, the projector you've got in the background is the one that my parents took me to at Madame Tussauds, and you don't get those things anymore. It's a great bit of kit. So yeah, I think, John, it's just a big round of applause for me and everybody else on Facebook who's listened to you. Sure, we could do this for another hour. I could get a bottle of red out. We could just sit here talking about old science fiction. Why not, eh? But that's our time. Thanks, John, for joining us. And
I hope we can do it next year, maybe.
Yeah, why not? I think we'll have to nobble a few of our comms people, but I think they'll be up for it. Why not, eh? But okay, thanks, John. I'll leave you to it.
Thank you very much.
Good. All right. Well, to everybody else out there on Facebook, I hope you enjoyed that. Your minds have been bended slightly, and you've got the answers to what you want. So just keep watching the Mars Perseverance. I hope you enjoyed our festival, what it's been through so far. Fingers crossed for some late nights and some clear skies. And so you can all just get out there and do what I tell everybody in every talk: embrace the darkness. And why not?
Absolutely.